Hello guys, so this is the second part of your presentation on concrete and steel. Now before we get into concrete and steel we need to look at two more things, which is what happens when water freezes and the effect that can have on buildings, and also porosity. So first of all we're going to look at what happens when water freezes. Now most things when they get cold contract. Water does a funny thing, it forms tiny little air bubbles, and this means it expands, and it can expand by up to 10%. And we can see as demonstrated in the picture here, if it expands and it's got nowhere else to go, it's going to cause pipes to crack and burst and cause sort of further damage to the house. Now the other thing that can happen as well when it freezes, if you imagine if water gets behind sort of flakes of plaster or render, in the winter when it freezes, just like sort of erosion that you would have studied in geography, when that freezes it's going to push apart, only very small it's to start with, but if that happens year after year after year, eventually we're going to get damage to brickwork and stonework and things like that as well. Now we need to protect ourselves, we need to protect buildings against this expansion. So one of the things we can do to protect pipes is to put this insulation on it. Now specifically we call this lagging. Lagging's just foam insulation, and it's just nicely cut, so it just wraps around the pipe nice and easily like this. Now within your house it should never really get below zero, and for the pipes to actually freeze and freeze to the extent that they're actually going to expand and crack, you actually have to get below 0 degrees, and you have to get below 0 degrees for a while as well to get that sort of level of freezing. So you don't really need to do this to the pipes inside your house because you're going to leave the heating on. If you ever go on holiday in the winter or something like that, you should leave the heating on very low in your house, don't turn it off. But in the attic or the loft, that might get below freezing. So if you've got water pipes in your attic or loft, those need to be lagged. Now new build houses, because we've changed the way that we supply water to houses, generally you won't find any pipes in the loft, but historically what we've had is we've pumped the water up into the loft, it's stayed there in a storage tank, so then it gravity feeds down into the house. These days we have really good water pressure coming from the street, so we don't need to use that system. So if you get a chance, have a look up in your loft and see what kind of water system you've got. Now the water needs to get to our house. Now for various reasons we bury the water a good distance underground. This protects it from just physical damage from cars driving over it, buses, just people treading and playing around with it. But also because it's deep underground as well, that's going to protect it from freezing as well. The use of plastic pipes as well underground. Plastic can expand a lot more as well, so plastic is a lot less likely to split than say copper. Okay. Now porosity. Porosity refers to the sort of the gaps between the gaps that appear naturally in the material. So a sponge or a flannel or a towel, something like that, that can soak up a lot of water, they're naturally very porous. If there are less gaps, then that's less porous and more towards sort of waterproof. Now we've got to be careful in construction with the terms we use. Buildings are generally water resistant. You're not wrong if you say it's waterproof, but things like submarines and plastic bags are waterproof. We need houses to breathe as well, so generally we make them to be water resistant. So if we have a look at some of the specific materials, and in your presentation you need to tell me about, okay, so you understand what porosity is, just like bending, just use simple definitions, simple diagrams. Okay, now if you imagine, if we look at this image here to start with, okay, Bradley, whatever his name here, is running along and he's put a bin bag on, so he sweats more, and that's a way he can sort of lose more weight. I wouldn't say it's a particularly healthy thing to do, but there you go. But imagine you're running along in a bin bag, you're going to get hot and sweaty, that moisture can't escape. Now we don't want houses to be like the bin bag, so that moisture needs to escape. So not all of the materials that we use on a building are non-porous. So tiles, roofing, sort of things like that are generally pretty much non-porous. They won't let water through. Windows, nice and watertight and weatherproof. But bricks and stone, over time, and I mean a long time, will let water through. But that also has the effect that they allow the house to breathe. So all that moisture that we're creating in the house from us sweating, and we sweat anyway, whether we're doing exercise or not, but we're boiling kettles, we're running showers, boiling pasta, all those sorts of things, that moisture needs to get out of the house. Otherwise, we're going to have very damp and mouldy houses, and they're very uncomfortable to live in. Now, other places where we want non-porous materials. So kitchens, if we spill something on the floor, we don't want carpets that are going to soak up all the liquids that we've spilled. So nice sort of non-porous floors, so stone, tile, lino floors in kitchens, not carpets. Also worktops as well, we generally want to be non-porous. Showers, again, wet areas of the house, we want those to be non-porous, okay? Remember, we can control the moisture in these by either having ventilation or windows that we can open to let the moisture out. Okay, so 2 things you've got to write up: expansion of water and how we can control that in a building so it doesn't cause damage, and then porosity, what it is, just a simple definition, back it up with a diagram of some sort, and then explain how that would lead you to choose certain materials for certain parts of a house. Don't limit yourself just to domestic houses as well. Think about big commercial buildings and things like that. So you could look at metal roofing and things like that. Okay, thank you very much. Good work with the coursework, boys. I'm off to fix my shocking lights. I've got these nice new shiny LED ones I'm going to wire in. Okay, we'll see you soon.